Great. I think some people are still joining in, but I will start with the introduction. Before we start the actual tech talk. Yes, welcome everyone to today's ALASCA Tech Talk. It's Tech Talk number 25 already, which is pretty amazing. For those who don't know me, first of all, my name is Ariane. I am ALASCA's community manager, and I have been moderating the ALASCA Tech Talks since January this year, which is always really fun. And also, if you're here for the first time, I think I will give you some background on the ALASCA Tech Talks. The ALASCA Tech Talks are a format established by the ALASCA Association. I think, hi, Mark, can you mute yourself?
Oh, I'm sorry.
Oh, it's all good. Thank you so much. The Tech Talks, yes, they're established by the ALASCA Association. ALASCA is an association for operational open cloud infrastructures. And what we do is strengthening digital sovereignty, or like contributing to this. And we do this by developing open source technologies that enable and facilitate building and running your own cloud infrastructure on the one hand. And on the other hand, we also like to talk about it, to raise awareness, to educate. And this is why we have the ALASCA Tech Talks, where we talk all things on open source developments in the cloud context on a very technical level. So yes, welcome again, everyone. Also, please note that this session is being recorded. I think you got the disclaimer when you entered, because we will be uploading this to YouTube later on, so that you can rewatch or share, and for those who couldn't attend today. So I think now we can dive in the agenda. As always, we will hop into today's Tech Talk in a few seconds. We will have plenty of time for discussion afterwards. Then we will look at some news and events from the ALASCA community, and then also announce the next Tech Talk for June. Okay, so what are we doing today? We are welcoming not one, but two ALASCA members, actually. We have Matthias Haag, the founder and CEO of UhuruTec, and Gerhard in product and services at Yorizon. Welcome to the two of you. Thank you for taking the time today. And yes, they will be talking about how they're building the Yorizon cloud platform. And I believe also explaining how or what role open source technologies play in this, which is super interesting. And with that, I am done with my introduction and will stop my screen sharing and give the stage over to you.
Great, thank you very much. So hopefully everybody can hear me. Let me share my screen. Schnapp. And I think you should see my screen now, if everything works fine. So great, hello everyone, and thank you very much for your time. Together with Matthias, we will dive a little bit into our Yorizon world. So my name is 𝗕𝗂𝗶𝗹𝗁, as Ariane already introduced me, working with so-called Yorizon. And I'm part of the products and services team within that company. And we are responsible to deliver a new European cloud. And for the intro, I just prepared a couple of information about how who we are, what we do, and where we are. And after about 5 minutes, I will hand over to Matthias to dive into our technical world within Yorizon. Who we are, two investors, PPT Solutions and Thomas Krenn, created a joint venture named Yorizon to deliver a new European cloud from Europe and for Europe, where the PPT Solutions is a subsidiary of the 𝗕𝗂𝗶𝘇liche AG, and they are focused on creating data centers using a pretty unique concept that give you some ideas about it later on. The good thing is we have a single source of financing, planning, construction, and even facility management of those data centers we will build across Europe. And 𝗕𝘂𝗶𝘶𝗃, also a pretty well-known company from Germany, one of the leading manufacturers in regards of customized server and storage system. And most of them started about, it's almost 2 years ago when the idea arises to deliver cloud services within Europe. And just to give you a brief introduction or an idea what we're talking about, we built the so-called 𝗕𝗂𝗶𝗶𝗃 cloud data centers using 𝗕𝘂𝗶𝗃 equipment inside the building, everything based on water cooling, where we now started with water cooling all the server hardware, and we're currently into development of water cooling the network equipment as well. So a couple of months away to be fully water cooled in these data centers. Together with our technology partner UhuruTec, we developed the open source based hypervisor to control, maintain, and of course offer our users the infrastructure. One of the key topics within Yorizon is green energy. So we use local wind parks if available and try to get only 100% green energy to fuel those data centers. And on the other hand, another important topic, we deliver the heat we produce into a local district heating network. So that's mandatory. And of course, together we created those data centers to deliver our services. Closer look to those data centers. Just the key topics in 2 or 3 sentences. The idea is to deliver modular design, which means you see on the screen the main entrance, and to the right side you see the white space on the first floor, together with the related technology infrastructure to run the white space, with the possibility to add another white space on the left-hand side of the building. And it's kind of a blueprint. So it's pretty easy to quickly build those data centers, where we're talking about building times in the month space area, still working on cutting those building times down. I already mentioned it, liquid cooling is mandatory. So our goal is to deliver at least about 80% of the heat we produce back to the district heating networks we connected to. And one pretty unique topic, the data centers are made of wood. So pre-constructed parts are put together on the construction site, and that seems to be unique in the meaning of we were the first ones even leading us to creating new certification methods with TÜV in Germany together. And such a building is almost done already. So the first one will open this summer. The second one, the second construction site, already started a couple of weeks ago. And in the first step, we plan to build 15 data centers across Europe, starting in Germany. And of course, based on the success, we will continue to add more and more data centers around in Europe. Closer look, but that's of course very, very high level. So Matthias has the possibility to dive a little bit deeper into that whole story. The idea is we offer application programming interface and API for our users, for our customers. Of course, on top of that API, we build our Yorizon portal, and behind the API with our portal, we have the whole technical infrastructure and all the software components to run the infrastructure. Few more hints what we deliver on another slide, but it's infrastructure as a service in the first step in combination with Kubernetes. And of course, we add additional services and features even this year and beginning of next year. When we sum it up, I just step through the animation just to give you an idea of what we're talking about. We will start this summer with infrastructure as a service and Kubernetes, platform as a service in the meaning of supporting different operating systems will follow up this year. Database as a service is under development. When I look at Matthias, plan is to deliver 2025 as well. And then we continue to add features and services up to software as a service or even more. With 2026, when the next data centers will open as well. And just a short look where we are, I already mentioned it, we will build data centers in Europe and only in Europe. And we start in Germany, in Heiligenhaus. The opening will be this summer. The next one, 𝗕𝗂𝗶𝘇liche in Germany, already started a couple of weeks ago. Yeah, and the next 13 locations are already bought, developed, and the construction will start 2026 as well. And with that short introduction, I would like to hand over to Matthias.
Thank you. I cannot start sharing until.
Yeah, I have to stop sharing before I think. Here we are.
Okay. No share. Where is it? Never. I use
so you use
okay.
Zoom as often as I use it.
Yeah. So now you should see the presentation, right?
Yeah.
Okay.
On the screen.
Okay. Thank you. So now we'll dive. So you heard a little bit about the Yorizon story and about the construction stuff, which is also very important to bring in some servers. Yeah. So So who are we from UhuruTec? So some of us know us maybe. We are building cloud platforms on bare metal. So we do the whole stuff, starting with bare metal provisioning, bringing on the OpenStack, bringing the OpenStack onto it, having a managed Kubernetes solution, which is called Yorizon, and as well some user interface, which is abstracting or visualizing the cloud resources, which we call UView. And as you can imagine, so for such a thing like Yorizon, everything is required. And so let's go through it. And but yeah, wait, there is something which you have to remind in first. So we are good engineers, I think, at UhuruTec, but we don't have every skill and every deep knowledge for all required technology. So I think we are good at the compute stuff, so the bare metal stuff, the server stuff, which is surrounding there. But there are also stuff like networking, which is very special, and you need partners for that. That was the first step we made when we started the Yorizon project. We onboarded some partners from our network. So one was a networking company which we are working together with now since more than 20 years, I think, at a foreign customer in the past. And now we are also onboarding some guys for the storage stuff, which are called 𝗕𝗂𝗶𝗹𝗁 from Munich. Maybe you know them. And for networking, they are called Roush Networks. They are also based in Stuttgart. So one thing here, which I would like to mention, is in the past, you had, of course, always this triangle of these three basic services for infrastructure. But in the past, you had some kind of firewalls between them. Yeah? So we had different teams, which we now have as well, of course, but we work together. This is something which is very important to bring this stuff up and running. And in a very well manner. Yeah, so this is something we learned from the past, I think, and so we try to make this better now. And for integrating these partners, you have to do some steps. Yeah, before I go into the technique, I want to mention this because this is important as well, I think. You have to establish some collaboration with all the people who are working together. Yeah, we have to place some common tooling, also like Git repositories and CI pipelines and whatever. Then you have this contracting stuff, which is also very time consuming, believe me. So we started early to automate this as well in a technical manner. So we are generating contracts in the meantime, and we are signing them online and everything which comes around, because yes, otherwise it would be very time consuming for us and it's not doable. And as well as this accounting stuff, so we have to write invoices at some point in time, and we want to have transparency against our customers and as well as against Yorizon. So we need some common time tracking or some interface for our partners to deliver their time tracking data, which goes directly to the invoicing. And you have to find solutions for this in a technical way, of course. Yeah. So I cannot go too deep into that, and this is a completely different talk. And just want to mention that. So let's go into the real infrastructure technique. So on the first or the lowest level, I would say we have this networking stuff. So we have the challenge to bring water-cooled hardware there, not in the first data center, but in the third one, I think. So we started to do some hardware evaluation with switch vendors, and this was the one big thing we did, and we also had some conversation in advance with these switch vendors, because you need a confirmation that they are able to deliver water-cooled switches in the future for us. And yeah, it was a very interesting part. So then basically what are we doing there? We are building a EVP and VXLAN fabric to have the ability to make tenant separation as well in the fabric, because it's not sure if we have only one big cloud platform or if will there be maybe several cloud platforms for bigger partners of Yorizon. So we need some tenant separation there, and we are prepared for this. The next thing is we are building a layer 3 only fabric, so there won't be layer 2 domains in the network fabric, which brings some challenges and a lot of advantages with it. We are building a high-speed fabric, so we connect each compute host with 2 times 100 gig interface, and the storage nodes are connected with 2 times 200 gig interfaces. So then we have the thing, but with this layer 3 fabric, you have this connectivity challenges. So the host is physically connected on layer 1 with the switch, of course, or with 2 switches, and then you have to assign him an IP address, and everything has to go automatically, of course, on our side. And so you have to make a good plan for this stuff, and as well for the Kubernetes and OpenStack connectivity, which is also not the mostly documented way we are doing it. So that's part of the challenge for networking. And then the next thing is the networking in general. So the orchestration of the networking and the standardization. As you heard, we are not building just one data center, or the plan is not just to build one data center, but a lot of them. So we need a good way to orchestrate all the stuff and to have a standard for all the provisioned networks, switches, and this is something which will still be developed. So we already did some standardization, and everything will be deployed automatically, of course. But I think we need some more flexibility in the orchestration, and that will be something for the future, which is not done already. And then we have this small word Sonic, which is there. Sonic is a network operating system. Maybe some of you know it. This was also part of the evaluation. So we started with a community Sonic, which is the upstream Sonic you can download from GitHub and compile it by yourself. And we had no, I don't want to say fun. It was rather pain, yeah. So we had to switch there to a closed source solution of Sonic for the first step, because we have to build something which is running afterwards, and we think it's not possible with the community Sonic right now. But this is something for the future, maybe. And I put it on a slide later as well. Then we have the storage partners. So we have Ceph and orchestrated with Rook operators. We have some challenges we have to face challenges with dual socket servers. So the servers which are responsible for the storage have 2 CPU sockets, which is something you have to take a special look in regards of storage servers. You have some network requirements, so we are still not there. This is something which is still in progress. That's why I cannot go too deep into the storytelling right now. So, but you can imagine storage is something which requires very low latency, and so we maybe will need some special network requirements there. Maybe not in the first day, but we are having this on the radar. So maybe there's this RDMA solution for Ceph, which we will need, and we will also need a counterpart on the network fabric. So this is such a challenge here. And there, of course, same stuff like a networking layer, orchestration, standardization. I could put this on every slide, I think, because we are building products. So the cloud platform itself is a product for us, and we have to challenge this orchestration standardization thing here very well to be scaled, to be able to scale the cloud platforms out as So then we are going to the 𝗬metal part. 𝗬metal is our product from UhuruTec we are using for automated bare metal provisioning, which is based on Metal-Cubed, which is an upstream project. And Metal-Cubed is using OpenStack Ironic in itself to do the bare metal provisioning. So OpenStack Ironic is the bare metal provisioning API, and Metal-Cubed is the abstraction for Kubernetes. And then you have a cluster API provider for Metal-Cubed to bring up Kubernetes clusters on bare metal with this stack. So for 𝗬metal, we had the challenge to make a redesign. So we had a first shot, and we recognized, okay, this first shot is nice, but this is a good first shot, and we have to do some redesign. So which means we had to split up a monorepo into several repositories, and we have to add some infrastructure services which are required for bare metal provisioning. So which means NTP, syslog service, DNS service, all this stuff you need in a special way to do this bare metal provisioning in a good automatic way. So this, and of course there are surrounding applications for this for Metal-Cubed in the Kubernetes world, which you require to have it. So for example, you would like to have a Git forge in it, to have your Git repository which contains all your provisioning information, which you then replicate to maybe some upstream Git repository, but you need this application as well here in the 𝗬metal layer. So then for the redesign, we also had this to implement a good way of versioning, because you have these upstream applications, but you have a lot of stuff around it. And for example, what is the next point? You have Kubernetes node images, and you have to make a common versioning which is clear for installations. So this is something which is also challenge of the versioning, and of course documentation. This is something which is also growing still, but it's also part of it. And so one big challenge was also the layer 3 network integration with a high available kube API. I have some picture on this for the next slide, which means we have this bare metal server with a Ubuntu Linux running on it. and you have two layer 1 links to the leaf switches, and you want to connect your server with an FRR. So we are doing BGP on the host, now advertising the IP address of the server to the fabric, and this is something which is not very complicated at all. But then you have to put all the stuff into the automation, which is not completely prepared for it. This was the funny part of it. And as well as the 𝗕𝗂𝗶𝗶𝗴. So you have good tools to bring up an IP address for 𝗕𝗂𝗶𝗶𝗴. Some people are using 𝗕𝗂𝗶𝗶𝗃 on bare metal there, which is not the best way in my opinion, but we are using 𝗕𝗂𝗶 as tool. And this tool is very cool because it has a feature to bring up the 𝗕𝗂𝗶𝗶𝗃 in a very good way for layer 3 networking, and I will show the picture later on. So now, other stuff we had to challenge, or we had to face was the image building process. We are building images for the 𝗕𝗂𝗏, the so-called ironic Python agent, which is a tool which spins up on the bare metal host before it gets provisioned, or which is used for the provision actually. So we have a build process for this, and we had to change it because the old build process was running in a virtual machine. We switched to Docker containers for that. As well for the node images. For node images, we used 𝗕𝗂𝗶𝗃 in the past. So we also switched all the image build process to disk image builder from OpenStack project, which is really a good tool to build images. And yeah, we made a lot of improvements to the images we had in the past. So we are, for example, for node images, we are now using a logical volume manager to have containment for several separate file systems, which I haven't seen in other images yet. So this is some part. Then we had if you do layer 3 networking, you cannot boot your server with a PXE boot easily. You can, but then you have to do some special in the network fabric, and it's not a layer 3 only fabric anymore. So you have at least a VLAN, which is used for the PXE boot, which is not layer 3 anymore. So, but we said no, we don't want to do that. Ironic has the ability to do a virtual media boot, but we have servers now from Thomas Krenn, which are currently not able to do a virtual media boot from an HTTP server. So we had to teach Ironic how to boot from a CIFS file server, which is working very well, to be honest. This was one funny part. And the BMC firmware is also something you have to keep in mind, because our provisioning goes from out of band. So we are addressing the server in the first step at the BMC, where we put in this virtual media image and boot it with it. But this BMC has an interface which is called Redfish. So it's a REST API to manage the server. And this is a standardized protocol in general, but I can tell you every hardware vendor has his own interpretation of standardization. This is something which is always funny, but there are some I would like to say thank you to the Thomas Krenn guys, which are doing really good support there for us, and which help us to get this BMC firmware image for at least for Yorizon fixed. And I hope, and some words later on to this as well. So regarding the layer 3 fabric, some words. So we have 3 control plane nodes, and I have to look at the clock because I'm running out of time. Sorry for that. So we have node IPs on every node, and you have this 𝗕𝗂𝗶𝗃 IP, which is common on all nodes, as you see here. And the funny thing is the load balancing actually happens in the network fabric. So if you access the 𝗕𝗂𝗶𝗃 from a service leaf into this spine layer, this 𝗕𝗂𝗶𝗃 IP has a load balancing here in the network fabric with ECMP, which is called equal cost multipathing. And you don't have to do all this stuff at a node level, which is not meant to do that. So this is just here some technical aspect. So then we have the UStack. So I have to hurry up, I think, because really we are very short of time. And yeah, I could talk hours, and every topic I have here is an own talk, I think. But yeah, let's go through it. So we are with UStack. We have GitOps-based orchestration of OpenStack, which is of course 𝗕𝗂𝗃 in it, and some surrounding applications. So we are not building something on top of 𝗕𝗂𝗃 or something. So 𝗕𝗂𝗃 is the very important part of UStack. And so we had to implement here some app of apps pattern for the GitOps stuff. We have some DevX tooling, which is a toolkit to make the OpenStack available on a virtual machine. So we deploy an OpenStack in OpenStack for development purposes and for CI purposes. I have a slide on this later on the next slide. Then we had to do the 𝗕𝗂𝗃 integration together with Cloud and Heat. So Cloud and Heat did most of the integration there, which are very happy for that. Then we are doing accounting and billing stuff. So OpenStack doesn't have, in other words, OpenStack delivers some numbers, some figures regarding which can be used for accounting and billing, but you have to bring them into a way where you can consume them directly for a billing purpose, which we are implementing in UStack here as well. Then we have the Keycloak integration on the roadmap for OpenStack, and we are having an API gateway in front of all that because you have some challenges for example, as well for accounting, where you need information of API calls which are not delivered by the OpenStack API itself. And we maybe also want to inject some authorization stuff into the API calls before it goes to OpenStack. So this is some reason for that. And we have also another topic on this. So regarding the DevX tooling, some short slide on this. So we have basically a developer which spins up his cluster, his UStack cluster or OpenStack cluster with our UGarden solution. So we spin up virtual machine-based Kubernetes, and we deploy in this virtual machine-based Kubernetes another OpenStack, which is then accessible by the developer. And could be, so this is one use case, and the other use case is the CI pipeline. So you can, at the end, you can test the deployment end-to-end in a virtual way. Of course, you have limitations. So if you look at the network, you have limitations there, but this is for the application itself and for developing OpenStack and 𝗕𝗂𝗃 very, very helpful. Just mention this. So then we have UGarden, which is a managed Kubernetes as a service. It's based on the sovereign cloud stack implementation of this. So we are not forking it, we are evolving it and hardening this sovereign cloud stack implementation. And then we identified also that we have common resources with UMetal at UGarden. So for example, we have a management cluster there, and the management cluster is basically the same. It just has a different cluster API provider. And so we started to share the resources there. Then for this managed Kubernetes, we need some accounting integration, because now you see that you have this Kubernetes service which is not part of OpenStack, and then you're lost with this accounting information you have there. So you have to implement it by yourself. And and another thing here is to mention is we will build it up with several management clusters, not one management cluster, which is a thing you might have in mind if you think about cluster API. We know that we will have a lot of Kubernetes clusters at the end, and then if you put it into one management cluster, this will have security concerns on the one hand and performance issues maybe on the other hand. And so we said, okay, let's spin up at least one management cluster for each customer which uses it, and manage this customer management cluster with the general platform management cluster. So I have a small slide for this as well. So we have here this platform management cluster, which creates the customer management cluster here, and this one creates the workload clusters of the customer and manage them as well. This is from the concept is here is similar like Gardener. Maybe you know Gardener as tool, but we are based on Cluster API, and we want to stay on Cluster API because, in our opinion, this is more the community tooling rather than Gardener. So we stayed for that, and this is from the concept here is similar, I can say. So then we have the fourth thing in our products is UView. So we have in the first shot we had some look at Yorizon, which is also an OpenStack UI. Then we had a look at Skyline as well, and yeah, we decided to do it on our own. Not because we think everything you do on your own is the best, is better. So that's why we had a look on the other stuff, but because of the way it's implemented. So the other user interfaces, web user interfaces, were state of the art when they were developed. Let's say like that. And we wanted to have some microservice, micro-frontend architecture for the user interface. This architecture has a lot of advantages. If you are to web development, you know that. I'm not that deep into web development, so I will not make some philosophy now rather of that. But this is also important stuff to have an integration with the Yorizon portal, which is the last point here on this slide. So because of the micro frontend architecture, it's easy for Yorizon to put this technical representation of the cloud resources into their portal, and which makes everything fluent. So then some story about the UView implementation. So we had a first shot using Crossplane, which is a Kubernetes tool to abstract the cloud resources. So Crossplane has some advantages. It's running in Kubernetes. It's replying very fast for requests. So the user interface is very, very quick. If you use it, but it also has some disadvantages, so it can run out of sync with your cloud resources, and this is something which happens very easily. So, for example, if you create a resource on the EIS layer, it might not be in your Crossplane instance, and you don't see the resource. And if you are using Crossplane as API, which is also possible, you are not SES conform, which is also some very important thing for the Yorizon project. So this was not possible to use Crossplane anymore, so we had to divide it out. But then we said, okay, using the OpenStack API is maybe not the best. It's mandatory, of course, but we have to implement some caching for this, because if you are doing a user interface, you want to have everything has to run quickly. You know that, yeah. You want to click and you have a reply if possible. So we implement some caching there, which is also able to get updates automatically from the OpenStack part, and yes, makes the user interface very quick, and will also be open sourced, of course. So then some slides about one slide about the architecture of the UView part, and maybe about the whole implementation part of the bare metal stuff. So we have here this big cloud, which is a customer cluster. So we will spin up some management cluster for each Yorizon customer. This means in this cluster we have an own EIS gateway for the customer, an own UGarden API, which means the management cluster of UGarden, and they have their own UView instance with all required stuff there, and so each customer will get his own URL for accessing the cloud platform itself. So the cloud platform itself is here on the bottom layer. So you have the OpenStack API, which is STS conform at the end, and you have this which is basically directly mapped here on the EIS gateway maybe injected with some authentication stuff to make this part a little bit more easy for us. And yeah, then you have also the ability to add foreign cloud APIs there, which is maybe also a topic later on. And then you have the accounting stuff here in this diagram. So you have the MQs, which provide you some accounting data, which are used by 𝗕𝘂𝗍𝗂 at the end. And from the 𝗕𝘂𝗍𝗂, you can put it into the accounting data, which is here now a topic. So it's currently at the moment, I think it's not a topic as far as I remember. I'm not into the development at all parts, as you might imagine, but this is something which might come in the future. And then you have the accounting here on the top right point, which is using the topic information and which is also consumed by UView to have all the stuff together. So what is closed source for this whole project? So we have a Yorizon portal, which is of course something which belongs to Yorizon and will stay there. But as I mentioned, you have UView integrated into the portal. So you have the technical abstraction is open source later on. So it's just really the Yorizon specific stuff, which is closed source. Then Yorizon is implementing some system API, which is responsible to onboard new customers for them, which is orchestrating our services at the cloud platform itself to create, for example, an OpenStack domain, create users in 𝗕𝗂𝗶𝗹𝗁, create users in OpenStack and everything together. And this is done by the system API, which is of course also Yorizon part, and which is also part of this business logic stuff, which is very special for a company like Yorizon, and which is, in my opinion, okay to keep this closed source. Then on the technical level, or rather technical level, we have these firmware drivers, which is a long story in my life. Yeah, so you have Intel CPUs, you have network cards and stuff, and they all have firmware, which is binary and which is closed source mostly. Yeah, so. And I still have hope that someday we will also get open source drivers for this stuff, but yeah, it's just a hope at the moment. So then, two other points we have at the moment closed source. It's the BMC and the BIOS of the servers. You see, it's very low level stuff, but you have to take care of this as well. For BMC, there exists a great solution which is called OpenBMC, and for BIOS, you have several opportunities like Core Boot, for example, which was formerly called Linux Boot. We are already in contact with Thomas Krenn to get this maybe changed in the future. And then we have this last point, which is the project which is in my heart. Yeah, so we have Sonic, which is a very great network operating system, and the community Sonic is currently not usable. Yeah, I had a talk on this in Dublin at the OCP EMEA summit, because the project is, in my opinion, a little bit broken. And so we hopefully are able to put in some effort and some love into the Sonic to make this community Sonic run on switches from at least some vendors at the start, with a special set of features for the start. But the important thing is to have a pipeline, a build process which is reproducible inside, maybe not completely reproducible, but better than right now. And you have opportunity to have a good image which is really usable at the first shot. And have features in it to make it administratable. So, and what is already open source and what we are developing? So basically all the stuff which comes around with our product. So we have this network orchestration stuff, which is gonna be implemented in the future, which is not already there. But we will open source the tooling around at least, and maybe also some blueprint and some configuration which helps you to bring up the network fabric by yourself, and to make this together in the community. Then we have the bare metal provisioning and with 𝗬metal, as I told you, which is completely open source, and which is the documentation is growing, and maybe then we can put it to ALASCA as well. We will see. Then we have this DevX tooling, which is very good tooling for implementing or to development stuff on Yahoo and OpenStack stuff. Then this all stuff which comes around accounting will be part of UStack, so will be open source as well. And last but not least, our UView, the user interface for the cloud resources is also developed under our open source license, and will be also able to be used by the community. So that's it. I'm through. Sorry for taking maybe too long, but yeah.
It's fine. I was just going to stop you, but perfect. Thank you so much. Yes, thank you for this wonderful talk. And I think we can dive right into questions that you have. I think there was one question in the chat at the very beginning.
Yep, about the size of the data center, as far as I have it in mind. Short summary, one white space consumes in a maximum 2 megawatt, roughly. We can add a second white space, as I mentioned in the beginning, so 4 megawatt for one location. That means 66 racks, where in theory we can add another 12, and of course increase the high. We're talking about 1.2 million virtual AMD CPUs. It's the EPIC 9754 we start in the first data center. We have 2.7 million gigabyte RAM. And Jesus Christ, it was roughly about an exabyte on SSD storage, not taking backup redundancy into consideration.
Okay, thank you. Are there any other questions?
Too much information.
I don't see any, but I'm sure that if any questions come up afterwards, people can reach out to you.
Sure, yes.
Nice. Okay, so if there is nothing else, then maybe I would hop onto some news from the community. Thank you again, Gerhard and Matthias.
You're welcome.
I will
Thank you
briefly
very
share
much.
my screen again. Yes, some news and events from our side. We will start with a look at the ALASCA Focus Hackathon with the UhuruTec Summer Party and the ALASCA Summit. And I know that Helena is here, and I think she can give us some information on the events.
Hi, everyone. Right, for the hackathon, we only have just a few seats left, and I do want to kindly ask you to please register. I will put the link in the chat again. We need that information for catering and so on, so that we can provide enough food for everyone. So I will be posting that in here. If you are planning on coming, then we would greatly appreciate if you want to register. We also have a Hedgehog document that I will also post the link here, so that you can put in, if you're coming or not, you can do that there too. But the first link that I'll be sending would be the correct one to put it in. And then you can also put in topics that you would want to work on during the hackathon. And for the summit, we currently have our call for contributions open right now until May 30th. And it would be great if you know that you would like to participate, if you have any topics in mind, it would be really great if you could also hand something in. Yeah, that would be that from my side, and I'll be posting the links. Thank you.
Thank you, Helena, for the update. Yes. Are there any questions to the both events before we move on? If not, you can always find the information on the website and write us an email. The contact info is always there. What else do we have? Yes, what else has been going on? Yesterday we have been at the 𝗕𝗂𝗋 Roadshow. 𝗕𝗂𝗋 Roadshow stopped in Dresden, which is very convenient for us. It was about digital transformation in the construction industry. It was a very lovely event. Marius, our chair, was there too to give a little talk about the necessity of data sovereignty. That was it, I think, from our side. What happened in May. So I would give this over to you. Other events from the community. I still have to save the date for the SCS Summit in September and the OSBA Connect in November. Are there any other interesting news or updates that anyone would like to share? Doesn't seem to be the case. I see Helena dropping the links to the summit and hackathon. Okay, if there is nothing to add, then the last thing I would bring on as news is that we are welcoming a new member to ALASCA. Excellent Technologies from Munich, I believe, are joining us. I don't think that anyone is here from Excellent. Otherwise, please speak up if I'm mistaken. But yeah, it's really nice to see the ALASCA community growing. And then we, as always, would like to invite you to also participate in the Tech Talks by maybe having a talk yourself. Open source technologies, everything around cloud infrastructures is interesting for this format. We do have some free spots available for the second half of this year. I think August, October, and November. So if you know something, if you want to hold a talk yourself or you have a suggestion, we are always happy about input. But yes, for June, we already have the next Tech Talk in store. We will finish the session with the announcement. We will welcome Tobias Nüttlich from 𝗕𝗓TN, and he will be talking about operating applications via Kubernetes in delay and disruption tolerant networks. So make sure to not miss this, and we would love to see you there. Again, thank you so much to our speakers today. Very interesting talk, and I wish everyone a wonderful weekend. Thank you for being here today, and I hope to see you next time. Bye, everyone.